Welcome to this class. This is the continuation of differentiation. Second method of differentiation, that is first principle method of solving differentiation problems. When we are dealing with first principle methods of differentiation, you add dy to y and add dx to x. This is the only simple idea that you would like to go away with. For instance, we are given y as b equals to x. We say that when there is y, you add dy, and when there is x, you add dx. Now we are going to say y plus changing y is equals to x plus changing x. This is how we solve differentiation problems. When there is y, you add dy. When there is x, you add dx. Now we are going to see. We say that then after that one, you take y to the other side of the equation, and we'll be left with dy here. We say dy will be equals to x plus changing x. When we take y to the other side, it will be minus y. So here, what? According to the question here, y is given as x, but y is equals to x. Therefore, now wherever you see y, you put what? You put x. Say that dy is equals to x plus changing x minus y. Now here, minus y. We say that minus y, and we say that y is equals to what? Is equals to x. Then we look at the equation. We have x and we have x. It is x minus x. It cancels. X minus x goes away. Then we're going to have dy is equals to changing x. Therefore, you introduce changing x in both sides of the equation. Both sides by changing x, both sides by changing x. Changing x divided by changing x, we are going to remain with 1. Therefore, dy all over the x will be equals to 1. Let's prove using general method of differentiation. We say y is equals to x. Using the general method of differentiation, you differentiate immediately. Here it is raised to the power of 0, and any number raised to the power of 0 is what? Is 1. Therefore, y will be equals to 1. dy over dx. And that is the relationship between the first principle method and the general method of differentiation. Let's look at one more example. Say that example 2. Let's call it example 2. We say that y is equals to x squared. So using the first principle method, we say that where there is y, you put changing y. Where there is x, you put changing x. Therefore, we say now dy, we say that y plus changing, let's say solution, y plus changing y is equals to x plus changing x. But the whole of this one is what? Is a square. The whole of x is a square. Now here, x plus changing x is a square. This one here we are going to expand it using binomial expansion. When we expand it, we will have something like x plus changing x bracket multiplied by x plus changing x. Now this bracket is multiplied by the whole terms that are in the second bracket. Let's isolate x into x plus changing x. Then we also go to the second one, which is plus changing x multiplying all this one, x plus changing x. Now let's multiply for x multiplied by changing x multiplied by x will get what? X square plus x times changing x will get x changing x plus dx times x will get x changing x plus changing x multiplied by changing x will get changing x square. Now here we look. We have x plus x changing x plus x changing x. You add them together, you get 2x changing x. We have x squared plus this will get 2x changing x plus changing x squared. Now this is what we are bringing to replace the whole of this one after expanding. Therefore, we are going to have y is equals to, say y plus changing y is equals to the whole of this one. We have expanded this one. The whole of this one is what? Is x squared plus 2x changing x plus changing x squared. Now we say now we take y to the other side of the equation, and we are left with only this one here. Y is equal to x squared plus 2x changing x plus changing x squared. This y is positive. When you move it to the other side, it will be negative. But y is equal to x squared. Now when there is y, you put x squared. Whenever you see y, you put x squared. Therefore, we are now going to have changing y is equal to x squared plus 2x changing x plus changing x squared minus. We say that y is equal to x squared minus x squared. Now we see we have x squared and we have also minus x squared. So they will cancel x squared and x squared because this one is minus. Therefore, we are going to have changing y is equal to 2x changing x plus changing x squared. Now we are going to introduce changing x to each term. We divide through by changing x, through by changing x, that is the rule, through by changing x, that is another step. Now we cancel changing x, cancel, changing x, cancel one changing x because this one is a square. Now therefore, we are going to remain with, say that changing y over changing x is equal to 2x plus, here we are left with one changing x after it has been cancelled by this, plus changing x. Here we are still having changing x on this side of the equation. If we are still having changing x on this side of the equation, we take the limit of changing x to be 0. Take the limit of changing x to be 0. Therefore, now we are going to say changing y over changing x is equal to 2x plus changing x, then the limit which is 0. And simply when we multiply this time with this, we are going to get 0. So changing y over changing x is equal to 2x, and this one is 0. This one now becomes our final answer. So this is example 2 under first principle method of differentiation. Now I'm going to leave a work that is going to be example 3, and you're going to solve it and you drop the answer in the comment section. Let's say exercise, we say y is equal to 5x raised to the power of 2. You do this one and you put it in the comment section and I will come and see. Thank you for our lesson for today.